Hello all, this is the video answer key to Unit A, Quiz 1. There's more than one version of this. The questions are the same. They may be arranged in different order, or the image could be slightly different. If you need version B's answer key, I can talk with you about that separately. But in the meantime, I'm just going to use this as the version that I talked through. Okay, the first 10 questions are matching. And it gives a definition and asks you to match it to a term. These are important terms for this unit. If you're using this video to help study for the test, this would be a great thing to use for note cards or however else you go about memorizing terms to ideas. So the first question is how much space something takes up. We have talked a lot about that being volume. Oh man. I want the right color. It's gonna be green. So volume. Volume is letter L. A mixture, if it has different parts, that's like an example would be if you have like sand on the bottom and then like water on top. That has a bottom layer and a top layer. Those are the different parts that we're talking about. So that's a heterogeneous mixture. Different or other is the prefix of hetero. If it looks the same throughout, the prefix homogeneous, the homo part of it means same. So this is the one that looks the same throughout. That would be like if you mix sugar and water. How much matter is in an object is called its mass, and it can be measured using a balance, or if you have a scale calibrated to grams, you could do that. In an experiment, the variable manipulated by the scientist is the thing that they are changing, that the scientist might decide to change like the time and then measure the height or something. So independent variable is the thing the scientist changes. The outcome that you're trying to measure is called the dependent variable. So that's A. 7 says something that is always true but doesn't explain why. That's going to be a scientific law. This is directly from the reading, and I know that there were a bunch of review questions from this. That's the difference between a law and a theory. A theory explains why something happens. It may not be organized as an equation, but it is both an explanation about the phenomenon and why it occurs. The smallest part of an element that is still an element is called an atom. And if you have more than one type of atom, so a pure substance with particles that have two of the same atom bonded together, that means the same atom means they're the same element. And if it's two of them, the prefix di means two. So this would be C. The next 4 questions are multiple choice questions, and there is one best answer. So in this case, question 11 says, use this particle diagram or model of matter. Those are used interchangeably. So a particle diagram or model of matter mean the same thing. They ask you to like represent a substance with this little key that we have been doing. So in this case, you have particles that are made up of squares and circles. This square and circle is the same as this square and circle. All of them are the same. All of the particles are the same, which means it is a pure substance. But because the pieces that make up the particle are different, it's not just a single element. This means that it is a compound. So for sure, 11 has to be B. Now, if you have a lemonade, if you have a pitcher of lemonade, if you've ever taken lemonade powder and stirred it into water, you see that eventually it just looks the same throughout. It's a mixture. You've got sugar and maybe some like lemon additives and water. So they are all mixed together, but it looks the same. It looks the same on the bottom of the lemonade as it does on the top of the lemonade. So in that case, if it looks the same throughout, because the word prefix homo means same, if it looks the same throughout, that means it's homogeneous. This is another particle diagram, and in this case, you have different particles mixed together. This is water, and this is some other solid. So you have a solid that is arranged on the bottom of the container, and then on the top of the container, you have the water, or whatever this liquid is up here. So in this case, if there's a solid on the bottom and a liquid on the top, and the particles are different, that means you have a mixture, and you have different parts. You have the bottom and the top. So if they have different layers, then you have a heterogeneous mixture. A pure compound means that the pieces that make it up have more than one atom, but all of the particles are the same. That's what makes it pure. So here's an example of a pure compound. Right here, you could look and see. This is a pure compound because every particle is the same, but every particle is made up of more than one type of atom. Over here, you have a mixture. You have some particles which are shaped like X's, and some particles which are shaped with this rectangle connected to two circles. So now to answer this question using words, if it is only a single element, that is not a compound. Air has a bunch of stuff in it. Oxygen is a really important part of air, but most of air is nitrogen. You breathe out a little tiny bit of carbon dioxide, so some of the atmosphere is carbon dioxide. There are other chemicals in it, like argon. So every one of these things is a different particle. So this is really a mixture. Air is a mixture of a bunch of different gases. If you mix salt and water, it's definitely not pure anymore. You have two separate types of particles. Salt and water are mixed together, so it's not pure. Now, if you have pure glucose, that means every single one of the particles in the container, it has 6 carbons and 12 hydrogens and 6 oxygens. This is the one that is a pure compound. It's more than one type of element that are all as a single piece. So 14 is D. The second page of this quiz asks you to investigate the experiment that is presented and analyze the data to identify independent variable and how you could observe it. So if you were going to actually do this experiment, you would see, here's how it works. It's a graduated cylinder, and usually we tilt it at an angle, and then you drop a marble down it, and you would time how long does it take for the marble to roll to the bottom of the cylinder. That's what this lab is doing. So you're going to make 5 different versions of this. In the first one, you don't put any sugar. In the second one, you mix 25 grams of sugar in it, but then you add the mixture to the cylinder, and then you roll the marble down it. And then you do it again with the third one, fourth one, and fifth one. So this is the experiment. You prepare 5 different 100 milliliter solutions that each have different amounts of sugar in them. And after they are prepared, then you drop a marble, and you do this technique to measure the viscosity. So you drop the marble, and you measure the time. In science experiments, we almost always make the first column the independent variable and the second column is the dependent variable. The scientists decided how much sugar to use, and then they measured the time based on the sugar. So this depends on how much sugar you have. That's why it's called the dependent variable. So in this case, the first question is, what is the independent variable? And so the thing that the scientists changed is the amount of sugar. So 15 should be A. Now, in class, I walked around with a mixture of sugar and water together. And if you remember what it looked like, it was just a clear, colorless liquid. Anytime you make an observation of a chemical in this class, you have to put that it is a clear, colorless liquid. This is the color. This is the state of matter. Those two things have to be observed. Color plus state of matter. You can certainly say more about it if you see tiny little bubbles, for example, or if you think that it is like moderately like translucent but not transparent. That's another thing you could say about liquids. So, but at a minimum, you must say the color and state of matter. The question 17 asks you to take the data up here and turn it into a graph. And so if you are doing this carefully, you understand that the independent variable should go on the x-axis and the dependent variable should go on the y-axis. So time in seconds, sugar in grams. Now, there's lots of different scales you can use, but if you go up by 0.2s, that was a good one. I saw a lot of people use that value. And over here, let's go up by 20s. 20, 40, 60, 80, 100, 80, 100. All right, 2, 0.2, 0.4, 0.6, 0.8, 1, 1.2. All right, so a couple important, all of the important things that need to be followed are identified in these sections over here. It says the graph should include. So first of all, you need a title. That's a really important prospect. Titles are always given as y versus x. So in this case, we are taking the time versus sugar. That's how you do titles. That's all you need. You can say the relationship between time and sugar, but the easiest way to do it is always say y versus x. X versus y technically means something else. So to correctly describe this graph, you should use the y-axis versus the x-axis. Now, the next point asks for to keep consistent spacing on both axes. So you can see like these lines go up by about, in my case, they go up by 10 seconds per line. I only marked every 20 seconds, which is okay. You can do that. But every line is always worth the same value, no matter what part of the graph it's on. On the x-axis down here, you can see that the graph goes up by 0.2s. So every line is worth 0.1 grams all the way past 1.0. So it continues going up. So that's what I mean by keeping a consistent spacing. Now the data should take up more than half of the graph. So halfway is like right here. So you got to have your y value that is higher than halfway through the graph. And your x value should be higher than halfway through its graph. So at 0 grams of sugar, we need to show that it had 0.51 seconds. It took 0.51 seconds. When you have, I have the numbers backwards. Time is going to be 0.2, the points. And the grams are whole numbers, 20, 40, 20, 20, 40, 60, 80, 100, 120. Okay, so if the container has 0 grams of sugar, it will take 0.51 seconds. If you have 25 grams of sugar, then you can take 0.64 seconds. So 25 grams is about right here. 50 grams will be 0.76. 0.76-ish, so that's about 0.76. 75 grams will be 0.91, so just over 0.9. And 100 grams, so that's this number right here is 100. 100 grams is 1.15. So this is 1. Man, all kinds of mistakes. 1.0. 1.2. So 1.15 is right below that. Halfway between 1.1 and 1.2. So you can see, if you're careful about plotting your points, it's not an exactly straight line. However, in general, the trend shows that as the sugar increases, the time it takes to fall down the cylinder also increases. A trend line goes as close to as many of the points as possible. It is not a connect the dots situation. So we're not doing this. We're not making a line graph. It's a scatter point, and then the trend that goes through it is some version of a linear equation. Okay, so these are the points that should be present in your graph. It takes up most of the space. All the axes are labeled with units. So you can see that I have units on both time there and sugar there. The independent variable is the thing that the scientist changes, and so they were changing the amount of sugar that goes down here. At point protectors are the little circles that are added. So that's a point protector. It helps us understand that the point is plotted correctly. And then the trend line is a straight line. It's not a connected dot situation. It's a line that goes as close to all of the data as possible. And so it could be help indicate what in general the trend is. That's it for version A. If you have questions, feel free to come see me. Otherwise, good luck as you study for your test.